Okay, now that we know what a vector is and how to solve for the resultant and break the vector into components, we're going to go back to our box problems that we did in the last chapter, and we're going to have an applied force at an angle. We're going to take that applied force and we're going to break it into its two components, its x and its y. We're going to solve for our F net and then our acceleration. So let's give it a try. Okay, if you remember how some rules for doing these problems, we're going to write down what we know. So we have a 20 kilogram wagon, that is our mass. Step one is we need to turn mass into weight, and you do that by mass times gravity. And that is 196, and you draw that coming down out of your box, 196 newtons. Now we have an applied force, our FA is 74 newtons at 22 degrees. If you think about pulling a wagon, you actually pull it in two directions. You pull it forward and you pull up a little bit on the handle. So this is going to be our x and this is going to be our y. And you're going to use your sine and cosine functions to break that into its two components. Okay, so when I break them into x and y, I get 68.6 newtons for my x and 27.7 for my y. Here is the new part. The wagon is not moving up and down, so the weight down has to equal the force up. Well, what's different here is we have two up forces, two ups, normal and y. So to get the normal, we're going to take 196 minus 27.7, and our Fn would be 168 newtons. And it says neglect friction, so over here I'm going to have an FF of 0. Now we have all of our forces on our box. We're going to look at it and do a right minus a left for our F net is equal to 68.6 minus 0. So our net is 68.6, and that is equal to MA, so 20A. And if you divide 68.6 by 20, we should get 3.43. All right, question 2. We've got two forces this time on the sled. Mom and Dad are pulling on this sled. Dad is pulling with force A, so we're going to break this into its x and y components. And Mom is pulling 22 degrees south of east. We're going to have to break that into its x and y components. But before we do that, we have to make sure we have the correct angles. So north of east, we go east and then north. So Dad's force is just 65. Mom's force is south of east, so we're going to go backwards 22. So we either do 360 minus 22, or we can call it a negative 22. Those will both work. But go ahead and break those into their x's and their y's. All right, after we break them into the x's and y's, we can see that the two y's basically cancel out. For A, determine the resultant force of A and B. We're just going to add Dad's x and Mom's x component, and you should get around 143 newtons. And then they're saying there's no friction, so our FF again is 0. So our F net is that resultant force equal to MA, where the M is 39, which should end up being an acceleration of about 3.67 meters per second squared. Okay, on this problem, we have our box. It's a 196 Newton box. That is our weight. What we need to do to that is find the mass by dividing by 9.8. 20 kilograms. That will be important later. The rope is held at a 30-degree angle. I don't know what the applied force is yet. We do know the acceleration is 1.5 meters per second squared. The FF is 10 newtons. Mu is 0.0578. And we are looking for FA and Fn. So we know that this is the x component and here is the y component. And we have an M and an A. So seeing those two together should lead you to get F net. And if you do F net equals MA, we get an F net of 30. Once we know the net, we can solve for the x because we know F net is equal to our right side minus our left. So 30 equals right minus 10. So our Fx has to be 40 newtons. So doing a little more backwards work here, we know that our x component is equal to the cosine of the angle times the applied force. And we know that the x is 40 newtons, and our angle is 30 newtons. So if we take our 40 divided by the cosine of 30, we get an FA of about 46.2. Now you should be able to use that FA to get Fy using sine, and then knowing that the normal and the y added together have to equal the weight, you should be able to solve for the normal. Okay, this next problem is going to put a lot of pieces together. We have our luggage. It has a mass of 12 kilograms. Turn that into weight. It's an FW of 117.6 newtons. We have a 47 degree angle. That is degree, not a big zero. 47 degrees. We also have a VI of 0.3, a VF of 1.7, and a time of 2 seconds. So you're going to use your old equation of VF equals VI plus AT to solve for A. And our A is 0.7 meters per second squared. You're going to use your A and your M to get F net. It's equal to MA. So if we multiply that by 12, we get an F net of 8.4. Then that F net can be used to find our Fx. Almost exactly what you did in the previous problem. I'm going to throw in my FF over here. So we've got F net is equal to right minus 7. So our right side is 15.4. That's going to be our x. And then we know that the x is equal to the cosine of the angle times FA. So 15.4 equals cosine 47 FA. Divide that 15.4 by cosine 47 should give you an FA of 22.5. Use that FA at 47 degrees to find your Y. Use the Y in the weight to find your Fn. And then the final step to get mu, you're going to use FF equals mu Fn. Okay, as you read through this next problem, there's a really important phrase right here, constant speed. And if you remember from our force problems, whenever you have constant speed, that means acceleration is 0, which means F net is 0, which means all the forces are balanced. So if we go to our box, and it was still 12 kilograms, and we are applying a 17 Newton force to the handle, and our frictional force is 7, that tells us that our Fx has to also be 7. They have to balance. We also could find our weight and our normal and our y's, but we can work it just with this. So we know that our x is equal to cosine angle FA. And this time we know 7 equals cosine angle 17. So we're going to divide both sides by 17. And that's going to equal the cosine of the angle. And to get the angle it's alone, we're going to have to do inverse of cosine. Okay, another box problem. We have our box. He's pulling with a force of 692. That's our applied, what he is doing. It's at a 36-degree angle. It's pretty heavy, a mass of 112 kilograms. We're going to turn that into weight. We know mu is 0.548, and we are looking for A. So what you're going to need to do is break this into x and y. If you know your y and your weight, you can get your normal. If you know your normal and your mu, you can get your FF. If we know x and FF, we can get F net. And once you know F net, we can do MA to get A. So give that a try. Okay, the last problem in this section was one that I had them try on their own. I'll get you started here. We've got our box. We've got an FA. Let's see, that's 4980. Had to read it there. 4980 newtons at 78.2 degrees. So you're going to break that into x and y. We have the mass of 621 kilograms. And turn that into FW, which will help you get your Fn. We have mu of 0.568, so we can get our FF, and then follow the steps from the problem before to get your acceleration.